1D convolutions.
Everything we learned about 2D convolutions works in one dimension too. Instead of sliding a filter over a grid, we slide it over a sequence.
In 2D, we had an n by n grid and an f by f filter. In 1D, we have a vector of length n and a filter of length f. The output has length n minus f plus 1. Same formula, just in one dimension. Padding, strides, multiple channels, all the same concepts apply.
Here is a concrete example. Input, a sequence of 7 values. Filter of length 3. Place the filter at position 1. Multiply element-wise and sum. Slide 1 step. Repeat. We get 5 output values. Exactly n minus f plus 1 equals 7 minus 3 plus 1 equals 5.
Where do we use 1D convolutions? Audio classification, time series forecasting, sensor data from wearables or machines, even natural language processing before transformers took over. Remember Module 10 where we used an MLP on character sequences? A 1D CNN could do that too. The filter slides over the character embeddings, detecting local patterns, like common letter combinations.
To recap the entire module, CNNs use small filters that slide across the input. Padding preserves size. Strides and pooling reduce size. Multiple filters detect multiple features. Weight sharing and local connectivity make it all efficient, and it works in any number of dimensions. That wraps up our introduction to convolutional neural networks.